Determine the Thevenin and Norton equivalent. That's the question. Determine the Thevenin and Norton. I'm not sure why I wrote lowercase t here. Should be uppercase. Equivalent. Of the circuit below. So that's our question. So somebody chopped this circuit and we want to find the equivalent of it, the Norton equivalent and the Thevenin equivalent. I'll come back and fix this, make it a capital T. Oh, that's the wrong one, wrong T. Bless you. The Thevenin and Norton equivalent. And my circuit is, we have a dependent source of 3 volts, voltage source here. I'm sorry, not independent. We have a 2K ohm resistor. I have a current source here of the value of what? 7 milliamp. A 5K and a 1K. And you can use any of the techniques that we know to find this. So if I want to do the Thevenin first, I need to replace this with a voltage source here, we'll call it V Thevenin, with a resistor here called R Thevenin. This is the Thevenin equivalent. If I want the Norton equivalent, that will be what? A current source pointing up, we'll call it I Norton, with the resistor in parallel with it called R Norton, and that's the Norton equivalent. And you can use any of the stuff that we learned before. What do I mean by that? I could actually here use source transformation. If I do source transformation right here, I can change this to a current source going upward of the value of what? 3 divided by 2, which is 1.5 milli, right? In parallel with 2K, another current source down 7 milliamp, $5K, 1K. Notice these two, I can combine them into one source. The value of that source, that 5.5 down, one is going up, one is coming down. The difference between them, it's 5.5 milliamp. 2K and 5K in parallel, the product over the sum, 2 times 5, 10 divided by 7, 10 over 7. If I do source transformation one more time, this circuit will be what? A voltage source, notice, is going to be plus on the bottom, minus on the top, because the arrow pointing down. The value of that is what? This times that. This is a K here. The K and the milli will cancel. That's 55 over 7. Ten over 7K, 1K, And I'm done. Here's my Thevenin equivalent. My Thevenin equivalent is labeled plus on the top, minus on the bottom. So when I look at that, I go, oh, if you want it that way, since you asked for it this way, that's V Thevenin. This is R Thevenin. And this is the Thevenin equivalent. Now compare this to this. That tells me V Thevenin will have to be what? Negative 55 over 7. Because this is minus on the top, plus on the bottom. We want it plus on the top, minus on the bottom. If you add these two resistors, what are you going to have? Is it 17 over 7? That's my Thevenin equivalent. I don't know if they want the answers in decimals. Yep. So if you divide them in decimals, what do we have? What's negative 55 divided by 7? It is negative 7.857. Do we have that answer? Yep. And the resistor, what's 17 divided by 7? 2.428. 2.429, yep. 2.42857, yep, that's the value. Now, if you want the Norton equivalent, guess what do you do now? Source transformation. If I do a source transformation, I have a current source pointing upward. The value of that current source is going to be this one divided by that. So negative 55 over 7 divided by what? 17 over 7. You do the math, that's negative 55 over 17. In parallel with a resistor, which is equal to 17 over 7K. And that's my Norton equivalent circuit. So a lot of people, once they find Thevenin, if they ask for Norton, source transformation. And if I divide negative 55 by 17, I get negative 3.235. Is that what we have? Negative 3.235 milliamp. I should have said milli here, because that's K here. So that was one of the questions. The other question, find the Thevenin equivalent. So the next question, it says find the Thevenin equivalent. And here's my circuit. 0.01. Oh, that's the one I looked at, Elia, when you were walking by. 0.01 times V1, it's a current source. Oh, I see where V1 is. This is 20K. (100 volts), and this is plus minus V1. Okay. I'm going to answer two questions because the question came on the web for me. It says, how can you do a voltage KVR right here when you have an open circuit? And the answer to that, when we say, what is V1? That means if you go and you attach now a voltage meter here, What is that voltage going to read? What is that meter going to read? So once you attach that voltage meter, what are you going to have? You have a closed loop now. You're forcing the current to go through it. So that's why you can do a KVL right there. So that's one of the questions I got. Now, but looking at this here, that circuit is open as of now. Let me just disconnect it. That circuit's open. That means there's no current going that way. There's no current coming from that end. It's a hole. It's not like water where we'll jump out of the wire. So all this current going to go where? Is going to go down. So this entire current is going to come down, go right there. So you have 0.01 V1, that's amp, current. So what's this voltage right here? So the voltage across that 20k ohm resistor, it's going to be the current times that resistor. 0.01 V1 times 20k. Let me just take a peek to see if that value milli or not. I forgot to look closely. Was it milli?
Yeah. V1 should be.
No, it doesn't say like that value in milli. So we'll leave it as V1. V1 might be in milli, but there's no milli in the unit. So when you do the math there, 20k times 0.01 V, 0.01 times 20,000, what do we have? 200 V1. Now again, you bring in your meter. Let's call this M4 meter here. That's your meter instead of voltage meter. So here's the needle there. That's your meter. It's going to measure what with that voltage there. And you attach it right there. You go, well, I can do KVL right here. Right? So minus to plus, that's a negative 200 V1 minus 100 volts, that's this one, plus V1 is equal to 0. Can we get what V1 is? Negative 100 equals 199 V1. So V1 roughly is what? Negative 0.5? That's your V open circuit. That's your V Thevenin. So this voltage here is my V Thevenin, which is V open circuit. Now I need to find R Thevenin. To find R Thevenin, you have independent and dependent sources. When you have both of them, last time I said, will be easy if you just connect this with the wire and find I short circuit. So let's find R Thevenin or I short circuit. So my circuit now will look like this. And now we put a wire there. Take a wire, attach it right there, and let's find the current coming down. That's I short circuit. And this is 0.01 V. Now this current doesn't all of it go down here, because there's some current coming in. I can tell you what that current actually going up. I know I short circuit coming in. I know this one leaving. That means the rest of it going that way. So if we do two equations by two unknowns, this is one of them. That's I short circuit. This is what? Oh, wait a minute. Wasn't V1 right here? Wasn't that V1? So what is my V1 now?
0.
0. What's 0.01 times 0? This current becomes 0. Because my V1 is 0. V1 was labeled between this end and that end. Once you put a wire there, you short circuited that, that means 0.01 V1 is also 0. This current is 0 now. So if I do a KVL right here on the right side, I go negative 100 plus 20K times the current through it. The only current going through it's I short circuit. So 20K I short circuit equals what? 100. I short circuit equals 100 divided by 20K. Is that a 5 milliamp? Can I find R Thevenin? It's V open circuit over I short circuit. And what's my V open circuit? My V open circuit is negative 0.5. What's my I short circuit? 5 milli. So what's that number? It's going to be a negative. We didn't discuss what negative resistor means. You won't hear that for a while. What's 0.5 divided by 5? E to the power of negative 3. Where's EE here? Somewhere I can't find the EE. I know it's so. Oh, EE, negative 3. And that's 100 ohms, roughly. So when I look at my Thevenin equivalent circuit for that, it's a V Thevenin of negative 0.5 in series with a resistor of negative 100 ohm. Are these the answers? Negative 500 millivolt, which is 0.5 volts, and negative 100 ohms. Yep. I know what you're thinking. How can the resistor be negative? Be patient. It gets worse than that. You know. This is nothing. Any other questions from that homework? I'll save this video, maybe I'll put it maybe up there as examples of Thevenin and Norton, you know. I'm sure I'll get 10,000 questions. Hey, you got a negative value for R Thevenin. I didn't make a mistake, trust me, that's okay there. Be patient.